because I don't know a whole lot about this RoboLink that they have here, but they asked me to come and do a presentation on the introductory to 3D printing. Because, well, my background is mechanical designer, and I've been doing it for a long time. Basically, if I date myself, I'll tell you I started out with a pencil and a drafting board. Okay, I don't even know if a lot of people will even do anything like that anymore. Nowadays, it's all gone from the drafting board, into programs like AutoCAD and other design-related software. Now into the parametrics, solid modeling, design, and parametric documentation. So we've really moved a long way in a short amount of time. I may look a little bit older than I am, but actually in my lifetime I've seen the manufacturing processes go from lots of money and a lot of expense and a lot of time and a lot of wasted energy to being able to produce something literally overnight. You fall asleep, you get this idea, God, it's going to be 6 months before that idea ever comes to. No. Get up, you go down to the printer, you throw your design in, and you try it. That's what I've been doing lately. So I've really seen this great thing come about, and it's all because of 3D printing. Okay, it was in the 60s and 70s. It's been around, but it was also started out as a process that was not affordable to the average person. Even some of the big companies didn't even start coming into 3D printing until just within the last 10 years or so. But this type of printing that we're going to talk about today is just an introductory basis. 3D printing can go so far. I mean, it literally is boundless. And what they're doing with it today is pretty amazing. So if I don't get too talky in here, I'll get the presentation started, and then we'll sort of walk through that process. And then what we'll do is we'll take a little break, and you can ask a few questions, and then I'll pass around some of our 3D printed objects and share with you some of the things that I've made and some of the things that I know about. Okay? So without further ado, let's get started. That's not the beginning. Let's start from the beginning. Yes. Okay? All right. Go ahead. Okay, so I'm just going to go ahead and read it out loud, even though you guys, I know you can read, but we're going to go ahead and go through this. So, introductory to 3D printing technology is open to basically everyone now, from your 10-year-old kid to your 70, 80-year-old grandparents, and you in the middle somewhere. Okay, so next slide, please. You might have to. Yeah, you might have to hit it through the animations. So, okay. So 3D printing is also known as desktop fabrication, or you've probably heard of additive manufacturing. It's a process whereby a physical object or objects are created from a 3D design using a machine called a 3D printer. We got that far. A digital 3D model is saved in an STL format and then sent to a 3D printer by SD card or Wi-Fi. The 3D printer then can print the design layer by layer, forming the physical object as designed. For creating an object, you need a digital 3D model. And you can scan a 3D object to get that model, or you can draw it using computer-aided design software, or you've probably heard it known as CAD software. That's what it means. You can also download objects from the internet. There are thousands of already pre-made objects that you can download. I don't recommend that. I recommend you get creative and make your own objects, but if you get bored and you have a printer and have downtime, you can print somebody else's design. And then you're free. Next slide. What can you make with a 3D printer? That's the big question, isn't it? Well, lots of stuff. I mean, what can you think of making with a 3D printer? What do you want to make with a 3D printer? Obviously, everybody has a kind of an idea what they could do with a 3D printer, or don't quite know yet what the capabilities are of a small home-based 3D printer. This one of my favorites, hits home for me. To be able to design prosthetics like this is a big one for me because these types of objects are very expensive by other means of production. People need to be refitted all the time for them, and so there's a whole gambit of this type of work going on in the medical industry that's helping a lot of people out in gaining more mobility for lost limbs. Okay, so next slide. Who can use a printer, and how does it work?
See the text and stuff.
I think sorry guys. Presentation.
Maybe it's just a timing issue.
Yeah.
Anyway, just about anybody, all of you guys in here, that's who can. A lot of the printers are easy to operate. The software that comes with most of the machines is typically very easy to operate. It pretty much shows you the bed of the printer kind of in virtual space. Then you take your virtual object and you place it on that virtual space. Orientation-wise, and we can get into a little bit later as to how do you place an object onto the bed of a 3D printer to make it print the best. There are some limitations to how objects are printed in a 3D printer of FDM style printer like we're going to talk about today. Once you've modeled an object using that software, you can create this format, which is either an STL or an OBJ file. They're pretty much the typical file format that you will use to export your models out once you've created them. And then you transfer those files on either SD card or Wi-Fi to talk to the machine and send that code to the machine to print that object. Yep, and once it warms up, it begins to print. And speaking of warming up, is this one going to print for us tonight?
Oh yes, it's heating up, and
okay, we're warming that up, so that's good. We're going to show you how one works. Actually, if you haven't seen a printer. How many people in here have seen a 3D printer working? Oh, most everybody has. That's good. Okay, a couple people haven't. That's good. So even if one person hasn't seen one, we're going to get a chance to do that today. Okay, next slide. Are there many types of 3D printing machines? Yes, there are. There are many types of price ranges for 3D printers on the market today. There will be more and more available as these machines begin to grow, and I don't mean that, grow. And grow and become more increasingly involved on a personal level. And I say that because that was my head in the front. Anyway, next slide. You can do freedom with design, fabrication with this tool that you have now. With the software and with the 3D printer, you come up with an idea, you fabricate, you make it, and it's useful. I'm going to use this as an example as a practical use for a 3D printer. Okay. What happened in this case was, well, I sat on my glasses. Okay, it's a typical thing that happens to people. All right, to replace my Ray-Bans, see, I almost did it again. $150, $200. Okay, but it just took me a couple hours on the CAD program, and not everybody can just jump onto a CAD program and begin designing glasses. But you will notice, and I've been doing it for a while, so that's how come I can do it. But you will notice that you can achieve that, and at some point, dorky or not, they do work. They actually, I can see you guys great, much better than I could before without them. But the point is that you can use glasses. You could use the glasses as a practical application for 3D printing in the home, something that might break down or something that you don't want to spend money on. And I was thinking about it earlier today when I was walking up my stairs when I switched the light on. What a great thing to start out with was a light switch cover. How easy can that be? Everybody can do one of those, right? Let's do a light switch cover and put it on our kids' bedroom. Okay, anyway. It does fully work. If anybody wants to see this, just feel free to check them out. Next slide. Here comes the fun part. The layers of 3D printing. Now with FDM printing and most types of 3D printing, that's why we call it additive manufacturing, because what we're doing essentially is adding material And most people are familiar with manufacturing processes that are machining, for example. That's taking away material off an object. So an object like I'm holding in my hand, a gear like this that has multi-levels in it and multi-facets. On a machine time, you would take some time to set that up and make that out of metal and cut away material out of a solid block. That's what we used to do it. This process is called additive manufacturing. Pass that around if you like. And what that does is it adds material on top of layer upon layer upon layer, creating an object. I like to think of this as, I like to look at it like this. It's like the old style printers used to be. You know, remember the line printers? Some of us don't remember those days. But if you do a piece of paper layer by layer, and you take that object layer by layer, if you think about it, by the time you're done with a whole ream of paper, you have a solid object in there. So that's the way I kind of try to think about layers and objects. Next slide. There are many types of modeling. This one here is called, first of all, fused deposition modeling. And it's a common method in which the part is printed by extruding the molten strings of material that melt together in layers to create an object. This is usually the least expensive method of 3D printing, mostly for home hobbyists and teachers. Selective laser sintering is another method, whereby more common in the industry for industrial prototyping. Laser is used to fuse together thin layers of powdered material, plastic, ceramic, or other materials, and then it spreads more powder on top, more powder on top, repeating the process to build the part layer by layer, again adding material each time. The next one, powder bed and binder printing. Similar to the laser sintering, an inkjet head distributes the binder layer in the correct location of the bed of powder, and then the most notable advantage is the ability to print dissolvable support material. Now when I say support material, I mean that most 3D printers that are additive like this can't just print out in space. So if I was printing something that was like a T object, for example, you know, your prints can't just float out there. So what it does is it creates, the software creates what's called a support material, and it just builds a very small ladder up underneath that area to hold that area out, and that's called support material. Now, a lot of these types of FDM printers will build that solid piece and you'll break it away. Other processes have different ways of dealing with it. The powder printers, basically you shake it out and the material falls out of it, and that's how the powder ones do. So they don't have support like that. They have powder supports, and then if they're a hard material, then what they'll do is they'll use a bath, and they'll take it out on a secondary process, dip it into the bath, and it'll eat away that support material, thus leaving an object within an object. For example, like a whistle, for example. You know, a whistle with the ball in it, right? So during this process, you could actually print that whistle with the ball inside of it, and when you're done printing, shake out the material, and the ball, of course, floats around on the inside. Thus, process that you can't really do by any other method. What else do we have? Stereolithography, a really, really good one here. This is where an ultraviolet light hardens a resin in a vat, and a print bed moves upward, creating a hardened layer until the part is complete. It can quickly create high-definition parts that can be machined. The resins are more costly compared to other 3D printed materials, but you can get your prints down to 0.25 micron level. So it's basically very, very high resolution. They use these types of printers, which you see in pieces and pieces up here in this resin, for doing dentures and jewelry. So a lot of people get high definition, also small models, very high definition models. Like it looks like there's a couple of them over there. Next slide. Many more people have access to making 3D objects, and they will have control of the progress of their own design ideas. I like this one particularly because I've been working for people for many years, making this and that, and do this and do that. Being a 3D printer now, as a hobbyist, I think of something that I want to make, and I make it. I just do it. You know, it's great. It's freedom, in that sense. If it works out, I could take it to the next level. So, I mean, it is a starting point for having something physical in your hand and saying, this is what I have in mind. Ensuring the development of more useful parts to print and in use in everyday life. You can create a new marketplace for those who wish to make, market, and sell their own products. So if you get a printer, okay, I'm going to make an investment on a small printer and I'm going to start making objects because I have this idea. People are going to want to buy it. So I put it up on Etsy, I put it on eBay. It's something that I'm using it, so why won't they use it? And you can do that. Everybody knows about internet marketing nowadays. So if you come up with a great idea, you come up with a prototype, you don't have to go outside and go, hey, can you make me a prototype? For the cost of a small printing machine nowadays, it's, 10 minutes of some guy's time to just tell you what he's going to do next with your money. So it's a good investment. You have to, it's not that hard anymore it's getting to the point now where it's easy enough to where anybody can do it. Next slide. Materials. What is PLA? And are there other kinds of materials? PLA is a polylactic acid. That's how you pronounce it. Polylactic acid, or PLA. It's biodegradable. It's a thermoplastic material. It's a thermoplastic aliphatic polyester derived from renewable resources, such as cornstarch. Basically what it is, it's cornstarch. It's from tapioca roots and sugarcane in some of the other parts of the world. PLA is the second highest consumption volume of any bioplastic in the world, and it's getting much more. They're developing all different kinds of new PLAs that are mixed with different elements to make different types of stronger PLAs. Some PLAs they claim are stronger than ABS. They are wonderful hard materials because they are basically inert, and they come from plants already. So it's completely biodegradable material that will eventually degrade in time. So it's a preferred hobby printing material. It comes in many times in a lot of different printers. It'll come in spools like this. You've probably seen PLA come in spools like this. Some printers come in cartridges. Other printers will allow you to buy bulk like this, and then you have to do a lot of feeding in the machine and whatnot. But these are the types of colors, and of course you take this, what does it equal? All these objects that you make or design with your software. Should I own one? Well, that's the question. There's many manufacturers today making them. A decision to own a 3D printer comes from what drives your creative needs, obviously. And how much printing do you plan to do? I mean, are you going to be every once in a while, is it going to be every day? You might find that you might start out once in a while and you end up doing it every day. But there are many print services available that will print parts for you. I know UPS Store opened up a service here in Mira Mesa. And so if you have a great design, you can go and spend more money having them print it for you. But they will. So like if you come up with a great idea and you just can't get to your printer, you can take that file that you created and take it to different places and have it printed on different printers. Because once you've created your STL file, that's your baby. You can print multiple times for years to come, whatever. Send it to somebody. It's digital. It's amazing. If you're making part revisions and you need to observe physical changes to your designs, you want to put something together and is it going to fit? Is it not going to fit? I don't know. Well, let's just make another one. It doesn't fit. Well, let's make another one that does. Okay, so run it again. It's not that bad, I mean, considering the time it takes to print in a job, somebody might say, well, gee, that's a long time. That's 4 hours to print just that. Yeah, but 4 hours is not bad considering how many weeks or months it might have taken you before to do something like that. So you just do 3 or 4 in a day or something, you get the right part. If you do not own a printer, make labs and incubators such as this, something like this. I don't know if you guys have heard of incubators or maker labs. They have them out there. They're like, you pay money to go to these things and you have a membership and you can use their machinery. A lot of them have 3D printers. That's how a lot of people get started. They don't want to invest the money in a 3D printer, and they want to try it first. but that's because it's expensive, and people aren't really ready to spend all that money yet until they're familiar with 3D printing. And I wanted to mention that, and this is where I actually got a chance to use a 3D printer not that long ago at the San Diego Central Public Library. If anybody doesn't know, they have some printers there on the 11th or 8th floor of this downtown library, and those printers are open to the public. So if you have a file and you're downtown and you want to do some printing, they will allow you to do that. UN Tran is there. Tell her I sent you, and you can actually go into that lab, and it's free to the public. It won't cost anything. They do take donations, but they're not required. So if you guys want to check that out sometime, you can. I think XYZ has a printer in there.
Yes, we also have our print over there.
And there's an XYZ printer there as well. Because we're trying to let people know that this affordable printer is out there. The size of a 3D printer can vary with the model or manufacturer. Most hobby printers take up about the same space as that of a large microwave oven. If using PLA material, the vapors are harmless and need little ventilation. And that was what I was going to say is my point on PLA as being such a great material because of that fact right there. There aren't vapors, and you don't have a hood. And I'm not sitting here with a mask over, breathing, this material because it's safe. The energy used really depends on how much printing you're doing. That's a given. The length of time it takes to print also is dependent on the detail, size, speed, and other factors. One of the biggest questions I always get is how long does it take and how fast is it? That's my answer every time. Well, it depends. What are you making? What resolution are you making that part at? Because most printers can run at least 3 different resolutions. A very low resolution, a medium resolution, which I usually run all my parts at, and then a higher resolution, which will run but takes so long to print something because it actually does about 5 times more layers than it normally would. So each time it goes to another resolution, it's actually putting down more layers in a smaller place to get that resolution. So it takes longer. 3D printers are becoming more affordable and accessible to the general population. That's us. And the file sizes are increasing daily, adding to the usefulness of this manufacturing concept. So I think it's a really, really good place to start making objects if you haven't already started doing things like that in the past. And I just wanted to show the difference between what we're doing in 3D printing sizes. This is a large printing machine right here that can do full size, full color helmets for a bicycle. This one over here, printed at 50 microns high. That's like 800 times. It's amazing. So they're 3D printing in the sub-micron level. And what's amazing about that, and you say, well, okay, that's great. Well, but nano machines, that's big now for the medical industry. They're making bots that are small enough to go in and do certain surgeries that we can't do right now because we can't get that small. So it's coming, it's really going to revolutionize the way we do medicine in a lot of ways. So from ideas to reality in a fraction of the time and cost overall compared to other conventional design processes, the future is now in 3D printing, and this technology is growing. So, if you kind of compare this to the days when the computers first came out, you had your first AT where you were swapping floppies. Okay, I'm giving away my age again. All right, so floppy disks, whatever. Every time you go through iteration, every month there's a new computer. So every year there's a new computer. It's already out of date. But what are you going to do? Wait? Because it's never going to stop developing. You don't wait. You go, okay, I'm going to wait. And then your buddy calls you up and says, I got a better one than you. I got a better one than you, just like cell phones are doing right now. Don't wait. Get started in 3D printing right away when it's affordable. When it becomes at the level that you can do it, that's when you start. When I actually spent a little bit more money because I've been doing it for a while, and it's a lot cheaper now. So you guys, I don't see how it's going to get too much cheaper than it is right now for starting out in 3D printing. I think the only thing that's going to happen is they're just going to get more advanced. And it's just like computers were they do the same thing. They just get better with time. You know, kind of like a good wine, they say. So from ideas to what? Human tissues, yeah. Automotive engines, musical instruments, nanotechnology, jewelry. Okay, I don't know what that is. But, I mean, how do we achieve that? We achieve that with a piece of software, okay? So we have this idea in our head. How do we make that occur? Well, we use software to make that happen, and then the end result is the machine that makes that happen. So many 3D printers will come with software bundled with it that's an interface for their machine. But that's not the software that gets you to creating objects. Usually that's done with some design software. Like I mentioned earlier, CAD software, some sort of a modeling program. And I'm going to get to, actually, if you guys want to write them down, I want to have them here. I think maybe it's on the next slide. I have some references for you guys where you can actually go get some design software. It's free, and you can get started with making 3D objects. If some of you are already familiar with CAD design, or how many people know modeling in here, or have ever done modeling or design work? Okay, just a small handful of people. Okay, great, thank you. Because that's really where it starts, right? That's your creative outlet. You think of it, you design it in the computer, and then you print that object. So how do we achieve that? What kind of software are we going to use? Well, you know, that's sort of a personal thing. You decide what kind of software you want to use to design objects. So here, I want to hold on this one right here because I want to share this one with you if you haven't already heard of Tinkercad. How many people have heard of Tinkercad in here? Nobody. Okay, great. All right, well, it's a good place to start. If you get a chance, write this down, tinkercad.com. And what you do is you'll go there to Tinkercad. It's made by Autodesk. It's hosted by Autodesk, who does AutoCAD. So they've been around for a long time. And you'll start modeling pretty much right away. There's a tutorial at the beginning of it. You sign up if you want to store your files there. And then you basically start designing. It's really easy. You take solid objects and stretch them and then move circles and squares and things together, additive parts, and then use the same objects to take away things to design objects. Once you've done that, once you've gotten to that point, you can use Blender is another one. These are free, by the way. You can go here and sign up and use these. Sculptris is another one. OpenSCAD is another. These are all free software design.
There's also FreeCAD.
FreeCAD is another one. There's probably a handful more of them. That's a good one, freecad.com. And there's probably at least two more that I don't have on this list that I can't really think of right now, but I'll have it definitely in the next show.
There's also 123D.
123D, but 123D, 123D, oh yeah, and then there's 123D Catch. Right, okay. So Autodesk has a numerous number of products that they're putting out right now for people to use, and I'm going to touch on that in just a minute about some of the other objects for scanning and whatnot. And let's talk about XYZ printing. At XYZ Printing, they have a lot of affordable 3D printer choices available to begin printing at any level, from beginning 3D print artists to advanced modelers, prototype engineers, and educators. I believe we have XYZ Printing has at least 4, maybe 5 different models now.
Right now, yes, we have 4 currently, and more to come.
4 different types of printers, and I believe if you guys get a chance to come up here and take one of these brochures up here to see what their different models are. Excellent. And the reason I say that is because they're affordable compared to a lot of the other 3D printers that are out today. XYZ has a great, they share their excitement in creating, and want you to be able to afford a printer as well. So, since they have the most affordable printers and they have advanced features from built-in bed scanners to dual heads for multi-color printing. And we can talk about what the difference between the printers are, between 1 head or 2 head. The DaVinci printer is just an easy 3-step process. This particular one has a scanner inside of it. the one that we're talking about right here. This one actually also
Gotcha.
does have a scanner in it.
Yes.
Okay, so this particular printer, and I believe it's probably the only one on the market right now that currently carries a bed scanner in the bottom of the printer. And what I mean by that is, for example, I'm gonna have anything. There we go. Okay, so DaVinci, that's a good guy. Okay, so DaVinci, this object I have, I want to reproduce this. So I can put this into this printer and reproduce it to this level. And there I'll pass this around and you can see the difference. There is some loss in it, but if you're a modeler, for example, and you use clay and you do modeling projects and you put that piece of clay in here, it's like firing it in the oven. You put it in there, you scan it, you print it, boom, it's done. And you can do multiples of them too. So I'm going to pass this around so you guys can kind of get an idea for feeling with the original object and a scanned object that came out of the printer. So it replicates objects. It will replicate objects as well as just printing something that you've designed. So editing the object. That's what we were just talking about. The software. Okay, so you design your part and then you put it into this editing software. And when it says editing, what it means is there's limited amount of editing at this level. And this is pretty much how all of the programs interfaces work with 3D printers. You pretty much already have your model built the way you want it when you put it in there. What you're doing at this level is deciding how you're going to put it on the bed, like I was mentioning earlier, because that matters. How you print your object on that bed, because it's adding material, it matters a lot, because you could print something this way, and it prints like this, or you can print it that way, and it prints all flat like that. And depending on how you do it, it may warp. There's little things to know about it in this way. But if you do it like this, it won't warp. And sometimes it takes practice to do that. So that's what this software does, is it places the object on the bed so you can see how it's going to print. Then, of course, you hit the button print, and it's plug and play. Once you get to that point where you put it into the machine, it will begin to print like it's doing right now. And so, next slide. Then there you have it. You make your little objects, print your fun stuff, whether it's just for projects or whether you're actually doing practical applications for prototyping. It's up to you. Where are you going to go with this 3D printing technology? What are you going to do with it? If you're interested in the XYZ printers that you see here, please see Frank, and he'll give you all the information that you might need about this particular printer that we have here today. And you can get it started right away with a new printer from XYZ Printing. Thank you guys all. I hope I didn't put anybody to sleep, and I hope I was informative. Now I'm going to ask, anybody have any questions?
Yeah, I have some questions. I was just looking online, like at this printer right here, and then that Noble printer that you guys have.
Right.
And
Yes.
it looked like it was saying something like resolution on the one was like 100 microns, the one was 25 microns. I looked at some of your videos. It looked like the Noble one seemed to have like better than 4 times resolution.
Oh, right. The Nobel 1.0, it's a different printing technology.
Yeah.
That's the one Thomas explained. It was
That's a
stereolithography printing. And we actually have some samples here that we can show to see the level of difference from the FDM printer to a stereolithography printer. So the stereolithography printer, it's about roughly 4 times more as detailed as our regular DaVinci printers, and they are used for more detailed production prototyping, such as jewelries and sometimes in architectures. So I'll be passing around some of these samples so you guys can see the comparison and see the difference in details.
I want us to share with you guys a little project that I just recently completed, and it is what I call the world's smallest ukulele. It's playable and tunable. I made this on the printer just the other night. I designed it so that the tuning pins are.
Is this a song?
What? No.
Did you fabricate the strings?
They're fishing line. The way I did it was basically, if you look down the edge here, there's these little teeny tiny holes. Those little teeny tiny holes, and all the holes in that were all printed. So all the holes in there were printed, and I just put some little fishing line through it and tightened it up through there. And yes, and you can tune it up. I did play it. I actually have a video on YouTube of me playing it. Yeah, so if you want to see that sometime, you're welcome to go on to YouTube and just look up 3D printed ukulele, and you'll see doing it in a print shop. Now, I also want to share with you guys. I was talking about scanning, and okay, so I've got this little project going on where I've been taking people and scanning them into little people objects. And I don't know if you recognize this one or not. But it's supposed to be me. And so what you can also do in this world of scanning is these were done on a sort of a larger scale scanner. So I want to share it with you guys. It's basically a scanner, handheld scanner like so. Okay? And you take an object, you plug it in your computer, and you walk around it, and you scan the object in 3D space. Once you've done that, you save that file, the STL OBJ file, and you can print it with this machine. People love these. Everybody who have made their little likeness of themselves, they have to have one. So I've been giving them a little likeness of that. Here's a fruit bowl that I did. This is my fruit bowl. Pass that out. And I wanted to also share with you guys the fact that the tolerances on some of these parts are not bad. I mean, they're actually pretty darn good. If you're a designer, engineer, and you make assemblies, this is a robot or a toy robot that I created, and it is done on a 3D printer. And one of the things that you'll see right off the bat is this flat surface underneath. I'm going to go ahead and hand that around so you can kind of get an idea. I'll pass that around. And what you're seeing there is the assembly all printed at one time. And it is printed on what's called a raft. That object that you see down at the bottom there is a raft. And you'll see the supports that I was talking about also on these parts. And when I was talking to you about the supports, you'll see those anywhere that there's a part sticking out. And here's a completed part. Once you pop all the pieces together, you actually can make your own choice. So pass those around. The legs might fall out of that. Designed that way. Now, I just brought some samples of some of the things that I've made, and I've made quite a few things in my day. Here's a watch holder, okay, that this is practical if you have a lot of watches. So I made this, and it actually holds I actually put my watches on here, but I decided to change that up. And we have a whistle that I was talking about earlier. You don't want to try that. So, and iPhone cases, everybody likes iPhone cases, so phone cases. Oops. Nuts and bolts, if you plan on putting a couple items together. Yeah.
Like that?
Yeah.
So you say nuts and bolts. So how robust are these as far as strength goes and being able to take?
Pretty strong.
I mean, because you got the hardness factor, but what about other stuff like ductility and all that other?
It's actually quite strong. Anywhere that there's a solid, okay, and you'll see, there's a good example. See that head right there on the end of the table?
Yeah. That
head. See that pattern on the inside. So whenever it looks solid, it creates a hexagonal honeycomb.
The honeycomb.
And structurally, I mean, you could sit a car on top of that, no problem. Usually when I show people some of my objects, I'll stand on them. So they're really strong.
Oh, what about it? Could you, create actual like if you had to create a nut that you could actually torque, would it?
There should be one
snap
coming
off?
around here. The little nut is coming around.
Oh yeah,
The
there
red
it
one.
is. Sure.
Check that out. That's actually one of the first parts I ever printed.
No bolt in that.
Yeah. Okay. Yeah.
So that's why that one's important,
Yeah. Oh, cool.
because I asked the same question. And actually, the bolts work great. I'm working on an assembly right now where I have pins holding it together. So I'm 3D printing dowels and putting things together with 3D printed dowels, and it actually works quite well. So Christmas time, I made a few little objects. So yeah, you know, like I said, you know, you guys do iPhone cases, you know, easy to design up a case. And now my phone, my personal phone that I use, has had the same iPhone case on it for about 4 to 6 months, and it's worked great. The one that I had before this one looked exactly like it. The reason it's not on here anymore because I set my cell phone sailing and it hit right on the corner, and it cracked the case right on the corner, but the cell phone was great. So it worked, and I was really happy, and I went and printed another one. It took me 45 minutes and cost me nothing. So, yeah, some of the practical things that you can do. Does anybody have any, how about you guys? Tell me what you guys are going to do with a 3D printer.
Oh, actually, I have a question.
Oh, yeah, go ahead.
Curious what the cost is of the all-in-one unit with the scanner?
The all-in-one scanner is $799.
Can you, I forget if you mentioned before, what's like kind of the general size or minimum size of an object that can be scanned?
Minimum size? Minimum size.
Like I imagine after a certain point you can't really get much resolution.
You can get pretty small. I had a guy come to me and show me a 3D printed object that was about the size of, geez, I'm not even sure, about the size of a pea. But what it was a helix, and it was a helix, and it was in a round circle, and they were growing tissue in it. And the reason they were growing tissue in these helical little objects, and he showed it to me in a one of those one of those little cases you put your contacts in. Anyway, tiny little thing. And so I says, well, really? Well, why are you using? He goes, well, the only thing we can use is PLA. We want to get a finer, even finer than this, you know. And I says, well, so I've seen how fine it can get because I've seen somebody trying to get it finer than that, and it's actually pretty small. I can't exactly tell you without showing it to you, but they are growing. They're like growing these little growing human cells in them, and they're using it because it's PLA, and it doesn't hurt the whatever solution they're growing in. So yeah, I don't know a whole lot about chemistry and stuff like that, but I do know that the parts that I saw were tiny little helixes, you know, shaped in a little C shape. So I'm not sure. The best I could do is maybe show you one of my small detailed parts that I have, and maybe that'll help. I do other things too, like for example, keychains. I love to make keychains. Pass that one around. That's a Plan 9 Ale House that I made a keychain for. And so I make, you know, different style little keychain objects and things like that because it's fun and I enjoy doing it. I use different types of things like glow-in-the-dark material. You can buy glow-in-the-dark material that's PLA and make your objects glow in the dark. This one does. This keychain glows in the dark if you light it up.
So that's a question I have, is the different types of material. I'm sure the PLA also, as mentioned, that will also change with time as well.
Absolutely.
I mean, so it's like, are you limited to a certain manufacturer for this machine, or
This
a certain
particular
chemistry
machine,
of PLA?
well, let me answer it like this. The way that a lot of manufacturers like to put it is that they want you to use their materials so that they can guarantee that your print comes out right when you use their materials with their machine because it's formulated to run on this particular machine.
Sure.
Right now, a lot of the material that you can get not good material. You know, I mean, you can pay $50 for a roll, you know, which is pretty much about a 5-pound roll of material, And the material usually comes in two main sizes. This is 1.75 millimeter and 3 millimeter diameter. Okay, the 3 millimeter diameter is made for like big stuff, larger objects, and it can't reach the high resolution that the 1.75 millimeter rolls can do.
Mhm.
But you'll pay about anywhere like for the good stuff, you'll pay like $50 for a roll. You can get it for like $28 a roll. If you look around. The $28 a roll, you get what you pay for sometimes. It's not going to be consistent all the way through. So the way a lot of the heads work is they'll push the material down through the heated nozzle, which is like a glue gun. So you can imagine yourself, it's a digitized glue gun. It's forcing material down through it, and it's laying it layer upon layer. And so there are materials that are not really to spec. So what happens is, if there's a void in there, it'll not push the material down, and your part won't print. So it'll have like a spot in it or something. Sometimes they have spots in them where they have a layer that looks like the whole part is separated in the middle. What happened? Sometimes it happens, it gets stuck, possibly. It's a machine. That happens every once in a while. I got mine down to where I never have any problems with it anymore. When I first started learning about the printers, it was a little awkward because it was just a new thing, just like any other computer or anything that you get familiar with. And then after a while, it becomes your machine, and you start making all kinds of stuff with it. So, can I ask a couple people around here, what do you guys plan on doing with your 3D printers? Does anybody have any ideas what they might do with the 3D printer? Yes, sir.
I'd probably print the 3D printer with a 3D printer.
That's a great idea. He said he'd print a 3D printer with a 3D printer.
We actually have a 3D printed robot around here. Where'd it go? Here it is. Where's computer, buddy?
No, I think what he means, though, and I do understand what he's saying, is, and it's actually being done and has been done for many years with the Prusa-style printers. A Prusa-style printer is a printer that is put together with basically threaded rods and 3D printed joints and stepper motors and some belts. Okay, and I think you probably saw that slide with my head on it, when it blew up like that. That was a Prusa printer. And you can actually make all the parts, including the feeder for the nozzle, yourself, and use a 3D printer to make more of them. Once you create your initial 3D printer, you can use it to make the parts for a secondary and subsequent other 3D printers. So, point well taken, young man. That's really good, because that's exactly what I would do with my 3D printer too, is make more 3D printers. That's a great idea. That's wonderful. Good thinking. So, with that said, any other questions?
I had a question about the stereolithographic. It uses resin, you said?
It's resin, yes, sir.
So can you compare that to the PLA stuff?
That laser sintering process is so much different than this. As far as comparison and material is concerned, you can get details so much finer with this type of a printer. You're not going to make bigger parts.
Right.
You're going to make tiny parts. So if you're going to make small parts and with a lot of good detail, say jewelry, for example, or dentures or something of that nature, then the SLA machine is the one to go with. It's going to do, the bed on an SLA machine is about that big. It's small. It's not going to do anything large. I mean, they have bigger machines, but gears, yes, absolutely. Yeah, but gears actually, I don't know if you saw this part here. Did you get a chance to take a look at this part right here?
Yeah, I did.
That's that's about as good as you're going to get with an FDM printer, I believe.
Right, I was just thinking like the other one where you turn the crank on it, which is very cool. I was just thinking like if that was going much faster.
Yeah, your STL is going to be.
How strong is a printed part compared to like a gear when we're talking about to a part that's manufactured in a press?
Oh,
know,
well,
is
there's
Could
a
it come
gear
close?
manufactured in a press. No. I mean, it's plastic. I mean, it'll work for something that you're going to only need a plastic part to do. for example, if you need a metal part in a gear,
No. I'm talking about plastic part that was just manufactured, you know, in the regular commercial way.
Oh, you mean if
where
like you were
they
to
mold it.
replace it with like a
Yeah,
a
you could replace it with a
machine?
3D printed. part,
It's
would it
hard to
be
tell
just-
without knowing, what the actual application
Yeah.
is in that case. But I will tell you that yes, you can replace a lot of objects, gears, and things like that in various machine, situations that could require a gear that doesn't take that much stress. You know what I mean? Because if
Right.
there's too much stress or anything, it's plastic. You're just going to break. But if you had a plastic one in there or one that's not taking a lot of stress, then certainly you could replace it with a 3D printed gear.
Right.
I would highly recommend it. I think 3D printed gears and mechanisms like the one that you are passing around here are probably one of the coolest things that 3D printing can do. Much like I was talking earlier about printing a part inside a part. Things that you can't get to. So if you're a modeler and you can get inside the part and create it, the printer can make it. Because it does layer at a time. So if something's enclosed in there, it doesn't care. It's going to print a layer at a time. By the time it's all done, it's help, let me out. But no, I mean, it will. It'll actually encase objects. I know people that work with them that do like half the model, okay? And so maybe they're going to do this thing with, I don't know, a ball, right? And they're going to put a crystal in it. So they'll print it halfway, drop the crystal in, and let it finish. It's enclosed.
Can you do the same sort of thing with the stereolithographic stuff?
No. Because that's actually completely immersed. On the stereolithography side, it's completely immersed in a vat of resin. And so what happens in that case is that a laser beam comes across and it's just going to harden UV light on just a very, very thin layer on the top of that. So it just hardens that little by little. So it actually goes the other way. It pulls up from the bottom, as opposed to building up this way. It actually builds the opposite direction. So, like, imagine the Paris, what is it? The Eiffel Tower that we print all the time. When we print it on the Novell, it prints upside down. It goes up, it sticks to the bed, and it comes up this way. So the base of the Eiffel Tower would be the first thing to come out, and it would do like this. So to try to put an object into that situation,
More an object different out. You can't put like a steel in there, but what about just like making the whistles?
You mean like with a support material holding it in? Yes, absolutely. You design that support material in. Yeah, it's a little more, it's a higher end tool. It's not really, I wouldn't recommend SLA for anybody that's starting out, introductory. It's kind of, I want to tell people about it because it's there and it's something, but it's really a little bit more advanced 3D printing. Yes, sir.
One of your slides, there would look like an engine block in there, metallic. What's that?
That's plastic. It's plastic. It's a real engine block, but they printed a prototype of it, and they did that one on one of the larger printer that you saw with the helmets on it. That's an object printer. They can actually do large objects, and so it was printed. And does it work? Did they ever put the machine together? I doubt it. But as a model, they definitely use 3D printing to do models. I was a model maker when I was this young guy's age, right here, and I used to love to make models. I'd build them all the time, glue the whole 9 yards, and quit selling it to me after a while. I wonder why. Anyway, but now I make my own models, which is kind of cool because I like this, for example. This is how I came up with this. So after scanning somebody, I couldn't really get the color of the skin down. That was always the problem. I couldn't find the right paint mixture. So I decided, why don't I just get material that's skin color, right? And then I just have to paint the hair and the shirt. So, you know what I mean? So I just said, okay, so that's what I did. So I just got material that's pink like this, and then now I get a chance to do my little model painting, and it's kind of fun. And it's like a little hobby, you can do. I don't know, people, I know that there's not a lot of women in this room, but if they were, they'd be going, yeah, I can't wait to do some Christmas ornaments, They get really excited about stuff like this because, it opens up a world to somebody that's at home, they can't get out, it's like, okay, so it's probably less than a lot less than my first computer was. But something like this is a nice little tool. You can make your cookie cutters, you know, which, by the way, I think I have my cookie cutter in here that I made. I do little renderings. I don't know if any of you are musicians, but I did a little rendering of a acoustic guitar here, and then I just painted it to make it look like, you know, a real guitar, but it's 3D printed. It's hollow inside, so it does have characteristics of a real instrument. Let me pass that one around too.
And what kind of support did you put inside?
That was done on a little higher end. So it had the dissolvable material in there. Remember I was talking about the powder and the dissolvable material? So that went into a tank, and the material that was inside the guitar dissolved. So it left a whole cavity, an entire cavity inside there. So the guitar actually is hollow, just like a regular guitar would be.
Do you have to print like all at once, or can you like make something like this and say, you know what, I want to change this and actually put a little bit of a top on it and put this in there and then build it up? Or does it have to be kind of hot and wet on there to put the next layer down so there's just a strong bond?
Well, usually when you put one layer on top of the other, it's going to bond.
Okay.
Yeah, so it's going to bond. I mean, what you would do is if you're going to do a top, for example, a box and a top,
Yeah.
you just do them side by side and then pop them on when they're done. Because, I mean, if you try to do one thing on top of another, you can do it, but you'd have to put a support material layer between them, which would break away when you pull the two parts out. Other than that, I would just print them side by side, straight up, or, you know, however is best for you on the bed. When you start to get into it, you start figuring out exactly how you want to lay parts in the machine. So, for example, if I'm looking at my bed and I have this model in space. Well, I'm going to put it on the bed. How am I going to put it? Because if I put it like this, it's going to build all this material in the middle here to support this top edge. So the best way to print it in this case is flat like this. So when I put it on my bed in the software, I put it flat on the bed like this, okay? And it prints without very much support material at all. There's a little bit of support material that goes in here, and a tiny bit that goes in here, and once it's printed, I just pop that out, it's done. If I was to print this on the side, it would build all this support material, which you can kind of see in the back of this guy here. You see that little material holding up the back right there? That's like a little ladder. If I wanted to, I could just break that away. It's really lightweight, but I use it because the skin. So how you put this the objects in your bed is something that you get into once you're doing the printing and you really want to learn more about printing. We're going to have another class in the future that is a little bit more advanced about exactly how to design for 3D printing. But what I wanted to do for all you guys that are here is to introduce you to 3D printing, what some of the capabilities are, where are we going, and maybe just get the juices flowing and say, what can I do, how can I get it? If you have any questions at all, you know, or if you guys want to see this slideshow presentation again, I can post it up on my website. And of course, you can talk to 3D printing over here. They have this wonderful machine. And if you guys want, feel free to come up and take a look over here at the printer in action, printing, if you haven't seen one, do so. Thank you very much, everybody, for coming. And please feel free to ask any more questions that you have. Thank you. Thank you. Thank you.